Salam jami'an, لكن our chapter today is about space geometry. We will start our first thing to explain is a Cavalier perspective. Cavalier perspective, it means how to draw a Cavalier perspective. It means how to draw geometric figure in space. Cavalier is the name of a math scientist. At first, two parallel lines are represented by two parallel lines. It means that you draw the parallel lines as parallel lines. Two equal segments are represented by two equal segments. Equal, you still draw them at equal sides. In a front plane, a figure is represented by a similar one. What does this mean? In a front plane, a square is represented by a square. A rectangle is represented by a rectangle. A right angle is represented by a right angle. But in a front plane, in a plane that is not a front plane, figures are not represented as the same, and we will see that in the second part, in the other part. Solid lines are used for edges that can be seen directly. These edges, you can see them, so you represent them by solid edges. But the lines that you can't see, that should be in the back, for example, are represented by dotted angle. We will explain this by drawing geometric figures. Second part of the chapter is about geometric figures in space. This is a cube, for example, or this is a tetrahedron. How to draw a tetrahedron, or how to draw a cube. So if I want to draw a cube, I will firstly draw a square. Then I will draw another square back of it, in the back of it. But this line cannot be seen, so I have to draw it as a dotted line, this edge. And also this one cannot be seen, so it must be drawn as dotted edge. This line can be seen, and this also can be seen. Connect the points, and this cannot be seen, so it has to be drawn as dotted. This is the cube A, B, C, D, E, F, G, H. For example, ABCD is in the front plane, so it's drawn as a square. BFGC is also a square, but it's not in the front plane, so you have to draw it as a parallelogram. You know that it's a square, but when you draw it, it's a parallelogram. For example, AEHD is also a square, but because it's not in the front plane, it's drawn as a parallelogram. For example, this angle B is 90 degree. Okay, in the front plane is drawn at 90 degree, but this angle F is also 90 degree, but because it's not in the front plane, it's drawn as an acute angle, but you use it as a 90 degree angle because it's a 90 degree angle. How to draw a tetrahedron? This is a cube. How to draw a tetrahedron? You draw the first edge, the second one, not too much long, and the third one, and you connect this one with this one, this point with this point, and this line is not seen, so you draw it as dotted angle. And this is ABCD. This is a tetrahedron. Then we have to draw, for example, a pyramid. We have two kinds of pyramids. The pyramid that is in Egypt, its base is a square, but because it's not in the front plane, we draw it as a parallelogram. So this is a parallelogram. We draw a parallelogram, a par. We take a point that directly above this point, or a little bit to the left, or a little bit to the right, it doesn't matter. I will take it directly. We will connect these 2 points. I will connect this point with this one, this point with this one, and this one point with this one. It's A, B, C, D, E. This is a pyramid. You do know that A, B, E, D, C or BCDE is a square, but you draw it as a parallelogram. Okay, this is how we draw geometric figures in space. Second idea is about plane. What is a plane? A plane is a set of points making up a flat two-dimensional surface. Any two-dimensional surface, any surface that is formed of two dimension, it has unlimited length or width but has no depth. Okay, any point, any two-dimensional surface is called a plane. A plane represented by a parallelogram or an acute angle by writing the name of the plane and one of the vertices. For example, let's go back to the cube, or we have to draw it again. If we did the draw example, if you do have a cube, if you do have a cube ABCD EFGH, for example, the square ABCD is a two-dimensional surface. A square ABCD between two brackets is a plane. Okay, it's the plane ABCD. The plane, for example, DCGH. DCGH also is a plane, is a two-dimensional surface. It's, for example, ABFE, it's a square, or ABGH. ABGH is a plane. Okay, so a plane is any two-dimensional surface. Okay, another example, if you do take a tetrahedron, ABCD. ABC, the triangle ABC is a two-dimensional surface, so ABC is a plane. ACD also is a two-dimensional surface, also is a plane. Okay, so any two-dimensional surface, any surface that has no depth is determined a plane. Usually a plane is represented by a parallelogram. When we have to draw a plane, we draw it as a parallelogram. When you do have to write the name of the plane, you write it as 4 letters or 3 letters or only 1 letter. So when you do example, when you do represent any certain plane, you write the name in the vertex, you say the plane P. Okay, but when it comes to 2 letters, it's a line, it's not a plane. Determination of a plane. What does mean determination of a plane? When you know exactly that, for example, 3 points determine a plane, it means that whenever you have 3 points, for sure there is a plane that passes through these points. Whenever you have 3 points, you will have a plane that passes through these 3 points. Okay, a line and a point exterior to this line determine a plane. Also, if you have a line and a point, you will find a plane that passes through these 2 objects. After that, 2 parallel lines always determine a plane. 2 intersecting lines always determine a plane. If you have 2 lines that are parallel or intersecting, you can find a plane that passes through these 2 lines. Part 5, relative position of 2 planes in space. It's a very important thing. You have what we call coplanar lines or non-coplanar lines or CQ lines. If 2 planes belong to the same plane, they are called coplanar lines. It means lines, we mean straight lines, lines that are in the same plane or included in the same plane. Same. If 2 lines are parallel, 2 lines coplanar in the same plane can be parallel. Sorry, this is not parallel, this is intersecting. 2 lines that are in the same plane can be intersecting or parallel or even confounded. For example, this is the line AB and this is the line AC. AB and AC are confounded lines. Or in another way, 2 lines can be non-coplanar lines. For example, each line belong to included. Each line is included in different plane. For example, if you have the plane P and D is included in P, but another line D prime that is not included in P, D and D prime are non-coplanar lines. Non-coplanar lines, then it means that they are not intersecting, not parallel, and not confounded. Another thing, relative position of a line and a plane. A line D can be parallel to a plane P, included in the plane P. This thing, it means the line D, it is included in the plane, and or intersecting. A line D can cuts a plane. This is dotted because you can say it in a point A. Okay. Now, relative position of two planes in space. Two planes in space can be parallel, like these two planes, they are parallel, or intersecting, like these two planes are intersecting. If you don't know how to draw this figure, you can draw it this way, because you need to copy this information on your copybook. So if you need to draw two intersecting planes, you only can draw a plane P this way, and this is another plane Q. These two planes are intersecting, and their intersection is this line delta. This is the line of intersection. Okay. Or confounded. For example, this plane P and this plane Q are confounded. They are confounded planes. Okay. Let's just give an example. If you do take a cube, A, B, C, D, E, F, G, H. For example, the plane ABFE and the plane DCGH are parallel. Plane ABFE is parallel to the plane DCGH. Okay, for example, the plane ABFE, this is the plane ABFE, and the plane the plane ABF, this is it, and the plane ABFE are confounded. It's the same plane. You will say that, but the plane ABFE is a triangle. The plane ABF is a triangle. The plane has no limits, is unlimited length. It has unlimited length and width. يعني ما بيوقف على AF بكفي. So you can say that plane ABF, it's the same as plane ABFE. So ABF and ABFE are confounded. Okay, for example, if you take the plane ABC, the plane ABCD or ABC, whatever, and the plane ABF, ABC and ABF are intersecting, and the line of intersection is the line AB, and the line of intersection is the line AB. Parallel planes. How to show this property is very important. How to show that two planes are parallel. If a plane P contains two intersecting lines, D1 and D2, these are two intersecting lines. This is the line D1 that is parallel to another line D'1, and this is the line D2 that is parallel to another line D'2. If two intersecting lines of the first one are respectively parallel to two intersecting lines of the second one, then the two planes are parallel. For example, if you have a tetrahedron ABCD, tetrahedron هو هرم البونجيس. I and J and K are the respective midpoints of the sides. And if we need to show that the two planes IJK and BCD are parallel, you can say that the line IJ is parallel to the line BC according to the midpoint theorem, and the line JK is parallel to the line CD according also to midpoint theorem. So the plane IJK is parallel to the plane BCD because we have two intersecting lines of the first one are respectively parallel to the intersecting lines of the second one. Okay, this is a small example. Okay, property 2. This is property 2. If two planes are parallel, then any line that cuts the first one cuts the other. Okay, and if two planes are parallel, then any plane cuts the first one cuts the other, and the lines of intersection are parallel. Okay, property 3. It's as the same as property 2. If two planes are parallel, any line that cuts the plane P cuts the plane P prime, and the lines of intersection are parallel. As you can see, FE and HG are parallel. Property 4. If I have plane P parallel to plane R and the Q parallel to the plane R, then P and the Q are parallel. If two planes are parallel to the same plane, then they are parallel. It's a very easy one, very logic. Property 4 again, so this should be property 5. Property 5. If a line D is parallel to a plane P and also line D parallel to a plane Q, then D is parallel to their point of intersection. Okay, for example, if you have a cube A, B, C, D, E, F, G, H. Line EF is parallel to the plane ABCD, as you can see. For sure, a line is parallel to a plane if it's parallel to only one line of this plane. It should be outside this plane, sure. And line EF is parallel to the plane DCGH. So, for sure, line EF is parallel to their line of intersection. ABCD intersection with DCGH is DC. And this is true. We know that EF is parallel to DC. So if a line is parallel to two planes, so it's parallel to their line of intersection. Also a similar one, but it's going to be property 6. If a line D, it's not very similar, yeah. If a line D in a plane P is parallel to a line D prime in a plane Q, and then D and D prime are both parallel to the line of intersection. Okay, I'm gonna draw it in another way. If you have, this is the plane P, and this is the plane Q, another plane, two planes that are intersecting along a line, straight line delta. Okay, if a line D of the first plane is parallel to a line D prime on the second plane, then D and D prime are both parallel to delta. In French they call it théorème de Trois. I don't know what they call it in English. Okay, if a line D and line D prime are parallel and they are in two intersecting planes, so they are both parallel to the line of intersection. And this is everything for today. يعطيكم ألف عافية and I will see you.